Hi everyone, so we'll start now.
Hello.
Hi. Mm, Okay, so we're doing more algebra today. Um, so the first thing we're gonna go over today is factoring. So factoring is basically the opposite of like distributing an expression. So if you have the expression, like let's say x squared minus minus 2x plus 1, you can break this expression down into two things that multiply by each other, and this is called like factoring.
Mommy, mommy,
Yeah.
mommy, come and check. Hey, Bashadi.
Huh? Okay. So factoring involves breaking down or simplifying expressions so that you put it in distributive form, or like a form that multiplies two things together. A number can have multiple factors, and there are many different methods of factoring. So we'll just go over one method or like a couple. Yeah.
I learned this type of method at school. Please, may I distribute it on the board?
Sure.
This is the type we learned. Assuming you have a number like 38, then you bring an arrow downwards. You bring an arrow downwards and find that can two numbers that can divide 38, which is Hey, why you didn't mention it? Mama and food.
Yeah, so that's kind of the concept we'll go for, but we'll do it with like not just with numbers, we'll also do it with like variables. So,
I'll try a different number. And the numbers that can divide 12 are 2, and 6. 2 and 6. Then you bring an arrow under the 6. What can divide 6 is 2 and 3. So you keep on dividing until you get two numbers that no number can multiply them. Then after you do that, you bring all the twos and all the threes. So 2 times 2 times 3. 2 times 2 is 4. 4 times 3 is 12. This is the method we learned at school.
this is kind of close to what we're doing today. I think what you're talking about is called prime factorization. Um, but we'll probably go over that like another time, just like not today. today I can show you what we'll go over today. Okay. So we're just gonna keep going. Okay, so let's say you have the expression 3x plus 15. So you don't know what the value of x is, you're just given that it's there. You need to find the greatest common factor between the two numbers. So what do you think the greatest common factor is?
5.
So it says 3x plus 15. So this is represented as like 3 times x plus, let's say, 5 times 3, right? So what's the common factor? It'd be 3, right? Because you have a 3 here and then a 3 here, right? So now you can just divide each of these by 3 and you get x plus 5. But then you need to still add back the 3. You need to still multiply this whole thing by 3 because if you get rid of the 3, these expressions are no longer equal. So we need to put back the 3. So then we get 3 times x plus 5. So that would be our answer. This is the factored form of this problem. Does that make sense to everyone?
Not really.
No.
Okay. So let's think of 3x and 15 as two separate numbers, right? So what all can divide 3x? Let's break it up into 2. Well, we know that there's the number 3 that we can multiply by something, and we know that there's another, we know that we can multiply 3 and x together to give us 3x. Does that part make sense?
Yes, please.
Yes.
Okay, so then, yeah? Wait, did that part make sense to everyone?
Not really.
Yes, please.
No? Okay, so let's say we have the number like 9. 9 you can write as, hold on, let me clear the screen. Okay, so let's say you have the number 9. 9 can be represented as 3 times 3, right? Right? So
Yes.
instead of a 3 here, let's pretend this is x. So our expression 3x is basically just saying 3 times some number x. That's what it's saying, right? And this 3x, 3 times x will give us this number 3x. So if we want to break up 3 and x, we can break it up into 3 and x as two separate numbers. Does that make sense?
Yes, please.
Yeah? Okay.
Yes.
So we have 3 times x plus, then we can split 15. We can split 15 into 3 times 5. Okay. So what is a number we see that both of these parts have? So this is like part 1 and part 2. What number do both of them have?
3.
Yeah, so they both have 3. So the cool thing is that you can take this 3 out. You can factor it out. So that when you write the expression, you can write it as 3 times x plus 5. So here the 3 is still being accounted for. You're just taking it out of the expression so that you can later multiply it back in and still get the same answer. Does that kind of make sense?
Yes, please.
So,
Yeah.
madam, please, you are trying to say that if you have like this equation here, this equation right here, all we have to do is write in a bracket, write 3 dot x plus 3.5. And anytime we get x in between these numbers, we can remove this x here. We can remove these 3 here. We can remove these 3 here, and the answer will still be correct.
You're not removing the 3, you're factoring it out. So what that basically means is that you're creating two things that you can multiply to each other. So instead of 3x, let's say we had like I don't know. Let's say we had like 9 plus 15, right? So the way this works is that you would split 9 into 3 times 3 and 15 into 3 times 5. Then you would factor out the 3. So you take this out and you get 3 times 3 plus 5, right? And this gives us 3 times 8, which is 24. So if we put it in factored form, you see we still get an answer. We get 24. But now let's make sure that that's the right answer. So if we do 9 plus 15, we also get 24. So basically what I'm trying to say through this is that when you factor this out, this 3 out, when you do 3 times 3 plus 5, you still get the same answer as if you were just to evaluate the original expression. It's just that in this case with x, we don't know what x is, so we can't add 3x plus 15 to give us a number. Instead, we can factor it out so that we get an easier expression to deal with. Does that make sense?
Yes, please.
Okay.
Yeah.
You guys should use the tablet. I beg of you. Like, not the tablet. It's getting distracted.
Okay. So, we'll move on then. I think maybe seeing some practice problems will help, like, you understand. Yeah. Whoever is raising their hand.
Please, where did the one go to? The 15, where did the one go to?
The one.
The one.
So basically 15, you can write it as 3 times 5. This is like a multiplication of factors. So the 1 in 15 just represents 10. So I guess you could represent 15 as like 10 plus 5.
Please, the fact that you said 9 plus 15 equals 24 and 3.3 plus 3.5. So 3 into bracket 3.5 to 3.8 equals 24. I don't understand.
Oh, okay, sorry. This is like multiplication, not dot. So okay, so basically when you look at these types of problems, okay, so basically when you look at these types of problems, what you want to do is so basically when you look at these types of problems, you want to see how many common factors there are. So as you can see, step 1 says find the greatest common factor between the two
Madam,
numbers.
please, could I explain it to her, this one?
Sure.
So what I was trying to say, you have 3x plus 50. You have 3x plus 50. And they say step 1 over here is to find the greatest common factor between the two numbers. And right here, it says 3, and 3 is right here. Then we'll divide 3 times 3 times 3x. You divide 3 times 3x. Then you factor this one out. And this one becomes, and this one turns to be x. This one becomes x. Then you divide 15 divided by 3, which is 5. Your 5 is here. Then put into parentheses or the bracket. So the 3 that you factored out, you bring it here. Then into the bracket, you write the x that was left. Then plus, remember we did 15 times 3. It becomes 5. The 5 right here, I'll add a plus to it. This plus, and add the 5 right here. Thank you.
Yeah. So basically, you want to find the greatest common factor between the two numbers, and in this case, the greatest common factor would be 3, because we know that 3 times 5 gives us 15, and we have 3x. So then, as he said, we factor out 3, and then we get x plus 5. Okay. Okay, so why don't you guys try this question, and then we can go over it together after.
Private message.
Yeah, please private message me.
Please, Mala, somebody join on the board. It is for the answer.
Yeah, I'll get rid of it.
The answer is 60.
Could you private message me?
Roger,
Didn't you hear what the madam said?
Roger, you ruined it.
Also, like, your answer should have an x in it. Like, you shouldn't get a numerical answer because you don't know what x is. So there shouldn't be an x in there. There should be an x.
Dorcas, please, could you stop writing on the board? Dorcas, please, could you stop writing on the board? Thanks.
Please private message me your answer. And your answer should have x in it.
Switch to the screen where it had the steps you should take.
Oh, yeah. Okay. Here. Oops. Okay, so here's the screen where you should see your, like the steps to do it, but the problem is 4x plus 20. Not, this one.
Madam, please, there are two problems there.
Oh, do the 4x plus 20. Don't do this one. I just wanted to show the question or like the steps. So this is the problem you should do. Sorry about the confusion.
Please have submitted my answer.
Madam, please, I've submitted my answer.
Please have submitted my answer.
Yeah, I'm getting to it again. Sorry about the delay. Okay, we'll go over the solution now. So maybe that'll help clear up some confusion you guys have.
Madam,
Yeah.
I got my answer correct. Can I explain how I got it?
I've already asked another student to explain. But you can do the next problem because we have another problem after. Is that okay? Okay. Do you want to start explaining?
Okay. So the problem is 4x plus 20. And we are going to find the greatest common factor between 4x and 20. And it's 4. So 4 divided by 4x is going to be 4. And
It's gonna be x, right? Not 4.
yes, please. Then 20 divided by 4 is 5. So the answer is going to be 4 into bracket x plus 5 bracket close. That's the answer.
Yeah. Does that make sense to the people that were a little confused before? Or is there still confusion? is there like still confusion? Does anyone have any questions or anything? No. You understand? Okay. Okay. So let's try another problem. Okay. How about you try this one?
A bit harder than the previous one.
It's a little bit harder because in this case, your common factor or your greatest common factor will include so just note that. I'll give you guys some time to try it and then I'll go over the solution.
Please, could you go back? Could you go back to the steps?
Oh, here, I'll just type them out. Oops.
Dara, please, you are writing, please, what is it? What is the greatest common factor? Madam is trying to say that in your equation, you will have to find x as one of your greatest common factors. Thank you.
Thank you.
Madam, please, will our answer include parentheses?
Oh, sorry.
Madam, please, will our answer include parentheses?
Yeah, I think.
So please, all those without the parentheses is wrong.
I don't think you need parentheses in this one, actually.
Thank you. Please, somebody's mute is on and it's making a bit of noise.
Okay, I don't know if I responded to everyone, but we'll go over the answer now. I think some of you guys got how to do it, so yeah. So let's, yeah. Okay. So basically, let's think about it like this. We have negative 9x plus 21x. So if we wanted to do this by factoring, what we would do is that we can split this number into negative 9 times x we can split this number into negative 9 times x plus 21 times x. Okay, so now we have factored, we have found two factors of the number. So the number negative 9x, the two factors are negative 9 and x. Then for 21x, we have two factors, 21 and x.
Madam, please, I was here when you were explaining. Please, may you go over it?
Oh yeah, okay. So you know how we can have a number, like let's say 6 times 3. 6 times 3. We can break 6 times 3 up into 6 times 3. So like as two factors, right? We have two factors, like 6 and 3, that make up the number 6 times 3. Does that make sense?
No, please.
Yeah.
Okay. Let me see. So you know how we can write 6 equals 2 times 3?
Yes.
So 6 equals 2 times 3, right? So the way, okay, so the way we can sort of represent 6 is using 2 times 3, right? So if we want to, let me think about how to explain this better. Okay, so,
Mommy, could you bring me another water?
okay, so we can represent 6 as 2 times 3, meaning that when we find the factors of 6, it's going to be 2 and 3. Does that part make sense?
Yes.
Yeah? Okay. So the same thing sort of applies here. We have this number, negative 9 times x. So we know the two factors that make up this number because they're multiplied to each other is negative 9 and x. And then here we have 21 and x. So we have our two factors of 21 and x. Does that make sense?
Yes.
Yeah?
Yeah.
Okay. So we can further break down negative 9 into two more factors, negative 3 and 3. And then we can also bring down the x. Right? And then plus, we can break down 21 now. So 21 is 3 times 7. So we can do 3 times 7 times
Please, can you
x.
slow down?
Oh, yeah.
Please, can you slow down?
Yeah, I can re-explain what I did. Okay.
Can you
So
increase your volume just a little bit?
what?
Please, could you increase your volume?
Yeah.
I can't quite hear.
Is this better?
A little bit more.
More? I don't think I can go anymore.
Okay.
I can just talk a little louder. Okay. So we have negative 9x and we have 21x.
Please, a question.
Yeah.
Please, is it like the factor tree?
Okay. Yeah, it's basically like a huge factor tree. So you're just trying to find all, I guess a better way to put it is that you're just trying to factor these numbers such that you can just pull out numbers out of it to get a simpler expression. So here, if we just like, so I guess one way to think about it is just to ignore the x. So if we ignore this x,
Yeah, I've muted
pretend
myself.
this x is not here,
I've not muted myself.
it's not here. If we wanted to factor the numbers negative 9 and, okay, let me try it like this. Okay, I guess this is a better way to kind of explain it. Okay, so we see that there are x's here, but let's just ignore the x's because we don't know what their value is. So let's just ignore it as like a factor. So we're gonna have our new expression as negative 9 and 21. These are the two numbers we have to deal with in order to factor our expression. So the factors of negative 9 are negative 3 and 3. And the factors of 21 are 3 and 7, right? Does that make sense, everyone?
Yes. Yes.
Okay, so here, what number do we see in common? We see 3 here and we see 3 here. So now let's add back in the x's we had before. We're going to add back in the x's. So we're going to get 3 times negative 3x plus 7x, right? Does that does that make some sense to everyone?
No.
Oh, it makes perfect sense for me.
Wait, I'm gonna clear the screen because someone else was drawing on it. You understand? Okay, that's good. Okay, so okay, let me try this. Okay, why don't I give you guys another problem? So ignore this problem. Why don't you do like 6x plus 12? How would you factor this? You can private message me your answers. Okay, I think I made it a little more confusing. So if you ignore the x here, that does not mean you can do 6 plus 12 and then tag on the x. That's not how it works. You have to, let me put this in
Yes,
other
it
words.
is all
Okay,
right. They're very.
so basically,
Madam,
yeah,
please could you put it on the very first version of this? That's the one I find more comfortable understanding.
Stop writing without being given their permission.
Wait, can I just explain something really fast?
Yes, you shouldn't
Yes, because I don't even understand most of what you said. Because Jeremiah or Roger is talking, blah, 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 blah. Yes.
Wait, can I just explain something really fast? I think this will help make it clear. So basically when you're trying to do a problem like this or you're trying to factor something out, it's basically the GCF thing all over again. You guys remember the cake method? We went over this like a couple classes ago. But remember the cake method? So within the cake method, the numbers you'd put in would be this number in front of the x and then this number over here. You'd have your cake method with 6 and 12. So if you do the cake method on this, you can take out a 6. So you're left with 1 and 2. So what this is telling you is that you have 1 times x plus 2, and then this all times 6. Does that make a little more sense or no?
This makes sense.
It makes sense? Okay. Okay, so then why don't you guys try doing
It makes a little sense, but still I don't understand.
what?
Ah,
Okay, so why don't you
now
guys try,
understand what John.
why don't you guys try this problem now? So not this one. Why don't you try like 7x plus 14? You guys want to try this problem and then you can private message me your answer? You guys want to try 7x plus 14 and you can private message me the answer?
Since you said you take it back to the original steps, I'm not comfortable with that one than this one.
Just a little.
And everything will be.
Yeah, you can do any method you want. Like it doesn't matter how you get there. It's just like getting the right answer.
I'm just a bit
I calculated. So he said that.
So, madam, please, could you send it to the original?
Oh yeah.
Please will the answer be in parentheses?
Yeah. Here you go. Okay, here's the problem 7x plus 14.
Me too. Come on.
Yeah, I'm good. I said I'm good. I'm good. I'm good. I didn't ask you to carry on talk.
Look at
Okay. I'll go over the solution now. So let's see. Let's first find our two factors that we need to, I guess, work with and find a common factor. So the first one would be 7.
Evangelina, please have you read my message?
What?
Sorry, I was talking to Evangelina. I was talking to Evangelina.
You guys want another minute to try and solve it? Is that what you're asking for?
Evangelina, have you read my message?
Okay, yeah, I'll give you guys another minute to try and solve it, and then I'll go over the solution. Oh, we're waiting for, I'm giving you guys like another minute to factor the expression, and then I'll go over the answer. Okay, can I go over the answer now, or do you guys still want more time?
Yes, you can go over the answer.
Maoli, please, were you out of class?
Okay, so basically what we want to look at this question is our first step is to determine, determine the factor or the numbers we will use to find the greatest common factor. Okay, so this is our first step. So if we look at our expression, we want to find the greatest common factor between the number in front of the x and then this other number that does not have an x. So if we use the cake method, let's see what we can do. If I have 7 and 14, what is the biggest number that I can pull out following the cake method?
7.
Okay, so let's pull out 7. So if I pull out 7, what am I left inside?
0 and 2.
Okay, yeah, so 1 and 2. Okay, so now we can set up our answer. So we know we pulled out 7. So let's write 7. 7 times. So now we have to pair up the x with one of these factors. So the original number that was in front of the x was 7. So that means once we divide 7 by 7, whatever this number is should be paired with the x again. So we'd have 1 times x plus 2. So our answer would be 7x plus 2. Does that make sense to everyone? Yeah?
Yeah.
Okay.
Yep.
I'm going to clear.
Madam, please, the assignment you gave us last week.
Yeah.
Give us last week. Can we submit it right now?
Yeah, that's fine. Submit it whenever you'd like.
Okay.
Yeah. Okay.
On the Google Classroom.
Yeah.
On the Google Classroom.
Yeah, that's fine.
On the Google Classroom.
Yeah, you should submit it on the Google Classroom. Okay. Do you guys want to try this question?
Yes.
Okay. Be careful of the negative. So if you have a negative and a positive together, what does that give you?
Negative.
Positive.
It's a negative. So your expression is actually 7x minus 28.
28, 29, 30, 31, 32, 33, 33, 34.
In this case, your answer should look like some number, parentheses, x minus some number. This is like sort of the form your answer should look in. So if your answer doesn't look in this form, then your answer is probably not right.
Madam, please, could you go back to this? Madam, please, could you go back to the steps?
Yeah.
The original ones.
Here, I'll go back to the steps. Okay, here are the steps. Ignore this problem.
Please.
Okay, I think you guys are starting to get it, which is good.
Madam.
Madam, please. Can we write? Yes.
Can you type your question? Because I think there's like a lot of feedback.
Please have sent my answer.
Yeah. The question, here, I'll send the question in the chat. Okay. We'll go over the solution now. So I'm just gonna go back to the other screen.
Please, may I explain it?
I've asked another student to explain. There's one more.
From the previous work, you said that this one.
Sorry, do you want to do this one, which is the next problem we'll do?
No, Madam, please, in the previous problem you gave, you said that the next problem, I'll be the one to show how it is done.
Okay, do you want to do this one, Ben?
Yes.
Madam, so the answer is for problem 12 is, that is 7x plus minus 28. The answer is 7 to bracket x plus minus 4. Is that it?
Yeah, this is the answer. But you can rewrite this x, I know this plus minus 4 looks weird, so you can actually rewrite this as 7x minus 4. 7 times 4, yeah. Do you want to explain?
No.
Oh, sorry.
Yes.
Alexis?
Yes, please, I want to explain.
Go ahead.
Everything you want to explain.
First, I get I do 7 divide 7 divided by 7 divided by x, and my answer is x right here, and I factor out the 7. I factor out the 7, and it becomes x. Then the greatest common factor here is 7. So I will do negative 28 divided by 7, which equals to negative 4. Then if I'm coming to bring my answer into parentheses, I'll bring back out the fact the as factored 7 and bring it outside of the parentheses. Then a positive times positive is a positive term, and here is negative. So here becomes negative right here. Then I'll bring my 4 outside here. Is that correct?
There should be an x right here. It should be 7 times x minus 4. Yeah.
Thank you.
Okay. Evangeline, you have a question?
Yes, I do. So minus negative 28 divided by 7 equals 1.
Can you give me 1 second?
Okay, that's okay with me. Mm. Yes.
Sorry. Okay, yeah, go ahead, ask your question. Yeah, Evangeline.
Me.
Yeah.
Brother said the answer was 7 into bracket x plus negative 4. And you said I can make it 7 into bracket x minus 4. His handwriting, it was negative 28. Divided by 7 equals 1. Or was it 14?
So negative 28 divide by 7 gives you negative 4. So when you put it in the bracket, the standard format is some number times x plus 4. Plus some other number. Right, so this is the standard form. So we know that this number is 7. So we'll do 7 times x. And then it'd be plus minus 4 over here. But you can rewrite this as 7 times x minus 4. Does that clear up the confusion, or?
Yeah, it clears the confusion.
Any other questions?
Roger, if you can't write properly with the on-screen writer, it's better if you text. It's better. Or you do. Yeah.
Okay. Okay, last question. Just type your answers privately.
So are we moving on to the next problem? That is
Yeah.
3x
Please, the
plus
answer
6.
in parentheses.
Huh?
Is the answer in parentheses?
Yeah, it should look like some number times x plus some other number. This is what your answer should look like.
Okay.
So that means it to be 7 into bracket x plus -4. Right?
Yeah, the 4
Okay.
the 4
Madam,
of the
please, could
like
you send
something
it
You
else.
to
have put
the
your
step?
microphone on. Off it.
Madam, please, could you send it to the
Thank
step?
you.
Oh yeah, I can
So
put
that
it.
my voice will echo. Thank you.
Wait, hold on. I'll go
Just,
back.
Yes.
Okay, and here the problem is not this. Okay, I'll give you guys like another minute or so to do this one, and then we'll go over the solution and then move on to the next topic. There's one more topic for today.
Okay. Madam, please, will there be any homework or assignments given? Or like an exercise?
Oh yeah, there'll be an exercise, but I think it's pretty short, like maybe like 10 questions or something like that. It's not very long.
Okay.
I'll post it like maybe like an
On
hour.
the Google platform?
Huh?
On the Google platform.
Yeah.
Yes. That's true.
I'll also post the answers to the previous homeworks, so you guys know what the answers is. The thing is that the answers that I have don't have any work with them, so
Oh,
I will go through your solutions and I will like
can you put on my camera? I'm showing the homework. I
huh?
made my mind to show it to you, but I couldn't submit it. So
Okay.
it's here with me.
Okay.
And my sister. Listen to me.
Yeah.
So the woman can type fast. Come, don't you rather use brush?
Okay. We'll go over the answer now. I think most of you submitted an answer. Okay. Okay. Here is the question, and here's the answer. So let's think about what numbers would be the numbers we'd want to find the greatest common factor of. What number should I pick?
Any number.
So yeah,
It would be better that give us 7x in bracket plus 2.
okay. So we're gonna pick 3 and 6 as the numbers that we want to find the common factor of, right? We're gonna put that in the cake method, and we're gonna get 3 and 6. So what's the common factor between 3 and 6 that we can pull out? What can we take out of the cake method here?
But it's very kind to me.
Sorry. 1 second.
Okay.
Okay. Someone is gonna explain how to do it. Sorry. Does the student wanna explain?
Yes. Okay. So
If you want to
first
see press
Wait, hold
this.
on.
we have 3x plus 6, and we want to solve it. So first we have 3 open parentheses x plus 2. So we have this because 3 can go into 6, and 3 goes into 6 2 times, and 3 is our common multiple over here. 3 will go into 3x once, leaving x alone, and that's the x right here. And the symbol, which is plus, and then we have 2 because 3 can go into 6 2 times. So that's the answer.
Yeah. So if we look at the cake method, I think that'd be easier to understand kind of how you get 1 and 2. If you get 3 and 6, you can factor out a 3, so that's where this 3 comes from. And so when you continue on to the next step, you get 1 and 2. So the number in front of in front of x is actually 1, and the number multiplied by 3 to get 6 is 2. So this becomes your inside, and then this stays on the outside. Does that make sense to everyone?
Yes, please.
Yeah? Okay, let's quickly move on to the next topic. The next topic is basically going to be like doing the reverse of this. So, we're going to skip this question. Okay. So we're going to do distributive property. So basically, when we factored something, we got some number times x plus some other number, right? Where y and z are numbers. In the distributive property, we're actually going to put this back in. We're going to multiply the outside term times the first term times the inside terms. So it's kind of a quick explanation. So the inside part we'll call the multiplier, and this outside part we'll call the term. So you're gonna break a sum of 2 or more numbers into individual numbers and then multiply them by another number and add the two new numbers together to get the answer. Does this sort of make sense?
No.
No.
Not at all.
Okay, so basically, you know how when we factor something, we got like, let's take a look at the last problem. We got 3 times x plus 2 as like from our last problem, right?
Yes.
We got rid of like the rest of the stuff on the screen so it's not confusing. Okay, so this is what we got in our last problem, right? So the distributive property or like this sort of idea is basically like you're gonna take this 3 that you factored out and you're gonna multiply it by x and then you're also gonna multiply it by 2. So your answer will be 3x plus 6. So you're just gonna reverse the factorization you did. Does that make sense?
So we're going to reverse the distributive property.
Yeah. Basically, you're just gonna reverse the factorization you did. Whoever is raising your hand, do you want to unmute your hand?
Please, as you are doing the distributive property, will you still factorize the number before you change it back?
No, I'll show you an example, I believe. Okay, so this is the type of like problem you'll get. So it's already coming as like factored.
Okay.
Yeah, so you don't have to factor it. Yeah, Evangeline?
Evangeline, ask your question.
Okay, we'll just move on. Okay, so this is like kind of how to think about it. So first, we'll take the multiplier and multiply it by one of the terms within there. So it's gonna look like this. So we're gonna do 5 times 2 plus 4 times 5. So we're basically gonna like distribute it in, I guess. So we're gonna do 5 times, so like that. And then our next step would be to do, we're gonna simplify these because we know 5 times 2 will give us 10. And then 4 times 5 will give us 20. And then we'll add them and we'll get 30 as our answer. Does that make sense? This is kind of how you do it.
Yes, please.
It makes a lot of.
Yeah.
So, madam,
So let's try this one. Wait, someone also had a question. Yeah, go ahead, ask your question.
I wanted to know if the distributive property is just the opposite of the one we did first.
Yeah, it is the opposite.
Okay.
So in some cases, you'll need to like factor an expression to make it easier to deal with, and then sometimes you'll need to unfactorize it so it becomes easier to deal with.
Okay.
So please try this question and then private message me your answer. Evangeline, do you have a question?
madam, please, could you bring it back to the steps?
Yeah.
Back to the steps.
Here are the steps. Let me do this.
Thank you.
Okay. Here's the okay. Um.
Excuse me, ma'am, my keyboard isn't working.
That's okay. When we go over the answer, you can check your answer. Will that work?
Message.
Okay. So let's go over the answer. Does anyone want to answer go over the answer?
Yes,
Like, explain? Yeah. Do you wanna explain how you got your answer?
yes.
I'll show the correct answer first. Oh my god. Sorry. Okay. Where did the question go? Okay. Here is the answer.
Okay. So first, as Madam said, we have to multiply the multiplier by the terms. So first we have 12 times x, and 12 times x is 12x, and that's what we have here. And afterwards we put our sign right here. Then we have 12 times 6, which is 72, and that's our answer.
Yeah. So just note you can't add these two terms together. Like, you can't combine them like numbers into one number because you don't know what the value of x is, so you can't just like get rid of it. Um, so it has to like kind of stay there. It's 12x plus 72. Does that make sense to everyone?
Yeah.
Yeah? Okay. Here's another one. So here there are actually two variables, so make sure you include both variables.
Hey, look at what my screen does. Go to my screen. Go to my name on the charts and press P. Ah. Hey.
Oh, please private message me your answer if you got an answer.
Okay, Madam Varina.
How many did get?
Yes. She's the one who mutes me.
Hmm? You have a question? Okay. I think we can go over the solution now. Does anyone like raise your hand if you want to go like explain how you did it? Like raise your like Zoom hand or something like that so I can see like who all want to do it. Can you guys hear me? Oh, okay, there. Um, raise your Zoom hand if you want to like explain how you did the problem.
Work for many, many, many years in order to take as much as possible.
Can I
Okay, if Evangeline, do you want to explain?
Yes.
Okay, here's the correct answer.
So multiplying 5 by x2 and 12y equal 5 hash 12y plus 5 hash x2 equals 60y plus 5x2. Since the hash cannot add together, since you don't know the value of x or y, we use the lattice method or the expanded method to do it. Is that
Okay.
correct?
Oh, yeah.
No.
Okay. Yeah. Are you still explaining or?
I say multiplying 5 by x2 and 12y equal 5 hash 12y plus 5 hash x2 equals 60y plus 5x2. If we are not sure of our answer, we can use the lattice method or the expanded method to do it. But if we use the lattice method, the expanded method, our answer will be different from the one we are using to do the problem.
Please, you can't use the lattice method or any other method to solve for it because there is no equal to sign.
Yes.
Yeah, so basically this is just an expression. Because you don't know what it's equal to, you can't solve for anything. But you're right in the way that you can like use another method to check if your answer is correct. So if we expand this and we get 5x plus 60y, what we can actually do is we can factor this and check that we get the same answer as we did before.
Okay.
So if we factor it, we can just pull out a 5 again, and we'd get 5 times x squared plus 12y if we refactor. So that's how we know that
So
an
you
answer is correct.
are looking for the greatest common factor.
Yeah. Okay. Does anyone have any questions or like not understand? No? Okay.
No.
The part that you said, the 5x plus 12y, someone is not concentrating.
Okay. So we'll go over one more topic, and that's called absolute value. So the absolute value is basically like anything inside the absolute value will always be positive. So if we take this example here, we have -5. We have -5 and the absolute value, it will give us 5. If we put 5 in the absolute value, it will give us 5. However, if we do negative absolute value of 5, like here, it's actually going to give us -5. Because this represents -1 times 5, which is -5. Does that make sense to everyone?
Yes.
Yeah. You said every number in the absolute sign is always positively charged. So why is it negatively charged in the sign?
Okay, so basically when you have these bars called the absolute value bars, this number, no matter what the sign is, if you put like negative infinity or you put like infinity, I don't know, it will always return the positive sort of number. So like, if you put in -5 into here, you will always get 5.
Okay.
Yeah, so basically like inside the absolute value, sign doesn't really matter. You just always take the positive version of the number.
Okay.
Make
So we
sense?
are always going to take the positive version of the number. That's
Okay.
-5.
What?
Please make it.
Oh, shoot.
On mute.
Sorry. Yeah, what was your question? I
Me?
couldn't. Yeah, did you have a question?
Yeah, I just said that it's always
Okay.
going to be.
Wait, could you repeat your question? I couldn't hear it because of like the background noise. So,
Who is insulting you?
okay. We'll move on then. Okay. So first we should look at the signs in the problem, and we change the number inside the absolute value to the positive one. and then we check the sign outside of the positive value. If there's a negative sign, we multiply that number by -1, but if there's no sign, just leave it as it is. So if we look at the example here, if we have like negative times the absolute value of -10, we will first, like our first step will be to take this absolute value.
Okay.
Oops. We will take this absolute value and we will make this 10. So our new expression becomes -1 times 10. And so this gives us -10. But if we see and there's like no negative sign in front, then our answer would just be to take this number that's in the absolute value and just make it positive. So we get
Please,
15.
can you start again?
Yeah.
Yeah? Okay. So basically all the absolute value does, like these bar signs, all it does is
Right.
it makes
did
a
you do?
number positive. So like
What did
all
you
this
do?
stuff. Okay, so all it does is that like if you have -10 inside of here, it's just gonna make it 10. That's all it does. And then if there's a negative sign in front, make sure you multiply by -1. Otherwise, like leave it as it is. Okay. So why don't you guys try this problem? And then you can private message me your answer. Oh, can we try the problem? Yeah. Um Can we all please try the question? Okay, I think we're all a little confused on how to do negative 10 plus 9. So negative 10 plus 9 is, let's say you have like,
Madam,
yeah,
negative 10 plus 9, is it also with association to the number line?
yeah. So if we
So,
do it,
madam, it's kinda so you're saying in the number line there's always 0 in the middle. From 1, 2, 3, 4, 5, 6, 7, 8, 9.
Please your numbers well.
Okay. You have 1 negative. You have imagine you're owing somebody 10 Ghana cedis. You're owing somebody a total of 10 Ghana cedis. Then the only money you have right now on you is 9 cedis. So if you pay that person 9 cedi, you'll be left with 1 cedi to pay the person. So negative 10 plus 9. Negative 10 plus 9 becomes negative 1 because you still owe that person 1 Ghana cedis.
yeah, so let's think of it on the number line. So if we start at negative 10 and we move forward 9 steps, we go 1, 2, 3, 4, 5, 6, 7, 8, 9. We'll end up at negative 1. So that means negative 10 plus 9 gives us negative 1. So with that information, you guys can try to solve it.
Please, what is this negative 1 for?
It should be multiplied by.
Thank you.
Just so like everyone knows, the answer is not negative 2. Because this is multiplied by. So if you know that, so you can rewrite the expression as negative 1 times 1, which would give us negative 1. So the answer is negative 1, not negative 2. Don't mistake this as like a plus. It's multiplied by. Does that make sense to everyone? Why the answer is negative 1 and not negative 2?
Yes.
No.
Here, let me clear the screen so I can like go over the answer. Okay, so we use order of operations.
She said it's negative. She said it's negative 1 because it's just like 1 times 1, but this time is 1 times negative 1 times negative 1. So it's the same 1.
Yeah. So, yeah, exactly. So first you use order of operations to solve the inside. And so you get the inside as negative 1, which is like, we went over that using the number line. And then you take the absolute value of that, which would give you 1, and then you have to multiply it by negative 1. So you get negative 1.
Yes.
Does that make sense to everyone? Yeah? Okay.
Yes, please.
Okay, try this one. It's a little more complex. But use the order of operations first to solve the absolute value, then take the absolute value. I think this will be like the last problem we do today, so I'll give you guys some time to do it, and then we'll go over the answer. Okay, I'll give you guys like another minute or so before I go over the answer. Just remember that like when the expression is in the absolute value, it's always positive. So even if the answer to like 12 times negative 2 plus 34 minus 27 is negative, your answer will always be positive. And just make sure you also follow okay. I'll go over the solution now. So the solution is 17. So I think like a common mistake everyone made, or like the way you should approach, I guess, well, how do I put this? Okay, so our first step is to evaluate the expression. So I think like where majority of the people made the mistake was doing the order of operations. So remember you have PEMDAS. So what this tells us is that we should do our multiplication before we do our addition and subtraction. So let's do that. So we get negative 24 because we do 12 times negative 2. And then we do plus 34 minus 27. So this would give us negative 17. Okay? Does that make sense? How we got negative 17?
Yes.
Yes.
Okay.
No.
No? So what we okay, so remember, I think this was our first lesson. We learned.
Madam, please, my screen went off. Please, could you re-explain what you just said?
Yeah. So remember when we learned PEMDAS or like board mass?
Yes, please. Parentheses.
Yeah. So here, let's like go through it. Do we have any parentheses here? Like anything that looks like 5 plus 3 or something like that? Do we have something like this? No, right? So we don't have to worry about parentheses. Are there any exponents in this expression? No, right? So let's get rid of exponents. Is there any multiplication in this expression?
Yes, please.
Right? So our first step,
Please, why is it that 12 times -2 is -24, but not +24?
so
Because it's more -2.
so basically our first thing should be to simplify the expression within the absolute value. So within the absolute value, like when evaluating the expression, the signs do matter. So if 12 times -2 is negative, we have to be sure to account for it to be negative. That's why it's -24 and not +24. Does that make sense?
Thank you. Yes.
Okay. So first we do the multiplication. We know 12 times 2 is 24, and then we just stick on a negative. So we get -24. Okay, so let's rewrite as like this. Okay, so then let's do, next, do we have any division? No, right? So no division. Do we have any addition? Do we add anywhere? Yeah, we add right here. So our first step, or our like next step, should be to add those together. So if we add those together, we get the absolute value of 10 minus 27. Okay? So now we're done with addition. Is there any subtraction? Well, that's the last step. We have subtraction. So if we subtract it, we're going to get -17, right? And the absolute value of -17 will give us 17. So the answer is 17. Does that make sense to everyone?
Yes.
Yes.
Okay. So that's it for today. Thank you all for coming. I will post some homework as well as the slides we used today on the Google Classroom right after class. And so you guys can work on that and then just have the slides as reference. And then once the recording is published, I will also post that as well.
Okay.
Do you have any final questions or anything?
No.
No?
No, please.
Okay, I'll see you guys next time. Bye.
Okay.
Bye. Yeah, you can.
Roger was insulting.
Yeah, you guys can resubmit, or like you can submit old homework. That is completely fine.
Roger was insulting me and my sister. He called me an idiot sucker. That's not fair. The fact that my sister was threatening you doesn't mean you have to insult me. I'm an idiot sucker. I'm not even the one who sent you the text message.
Roger, please, not be rude. We are all friends here.
Say it again.
I'll like fix permissions next time so you guys can't like message each
Hello,
other.
Varini.
Yeah?
Can you hear me?
Simple.
Please, some people were teasing each other on the platform.
Can you all hear me?
Yes, please.
Yeah.
I want you all to appreciate the fact that your instructor is doing so well to impact you all on Saturdays. She's presently in the USA. I think it's 7 a.m. at the moment every Saturday. So the least you all can do is giving your best, be in good behavior, and desist teasing each other. I saw quite a lot of things that was happening on the platform, and the exchange of messages on the chat is totally unnecessary. You all have to apologize to your facilitator not to do this again.
Please, I'm sorry.
Please, I'm sorry.
Do you
Please,
assure?
I'm sorry.
Do you assure? Oh, I
Sorry.
hear you. I hear you. Do you assure not to do this again?
Yes.
Yes,
Please. You all
Yes.
are amazing
Yes,
colleagues.
please.
We see all
Madam.
the hold on. We see all the amazing stuff you all are doing in terms of cooperating and being forthcoming. Please, we want you to keep it that way, okay? Please.
Yes, please.
Very sorry, Varini.
It's okay. Okay. Thank you all. I'll see you next week. Bye.